If we're required to do an integration similar to this, where we've got the integral of 1 over x squared minus 8x plus 30 dx, we've not at the present time got any technique that allows us to do that. There's no trigonometric substitution we can do as it stands right now, looking at that we can actually come up with a substitution and do it. So we need to develop a technique, and one of the techniques is called completing the square. So let's just talk about completing the square, then we'll come back and we'll do this integration. The numbers 1, 4, 9, 16, 25 are what we call square numbers. And they're called square numbers because they are an integer squared. So 1 is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc. So they're called square numbers. Quadratics are of the form of x plus a squared or x minus a squared. Now they're called square quadratics because if you expand this out, you get x squared plus 2ax plus a squared, and if you square this one out, you get x squared minus 2ax plus a squared. So these are called square quadratics. So the technique of completing the square is to try and make this expression here, this quadratic, comprise of a square, and then there'll be plus some residual bit left over that because we've got the plus 30, because all of them can't be expressed just purely in this form. And there is something left over that has to be added or subtracted. And the process for completing the square is fairly straightforward. So we'll just look at x squared minus 8x plus 30. We write it, first two terms as they are, and then leave a bit of a gap and put plus 30 out here. Now we've got to add something, we've got to combine this something to make it into a perfect square. What you add is the coefficient of x, including the sign before, so it'll be plus negative 8 over 2, always divide by 2. So if this was plus 8, it would be just plus 8 on 2. Always add that squared. And at the moment, that's not going to be true because we've added something. Whatever you add, if you subtract it, then if you add something and subtract it, that's 0. So we've still got x squared. This is all still x squared minus 8x plus 30. Now that's x squared minus, now because you've got minus 8x, this is negative 4. So we just put negative 4 all squared. And this will be equal to negative 8 on 2 is negative 4. When you square that, you get positive 16, so you get minus 16 plus 30. So that's equal to x minus 4 squared, and minus 16 plus 30 happens to be plus 14. What you've done there is completed the square. If you multiply that out, you get x squared, and then the outer and the inner, you get negative 8x, and then when you square negative 4, you get positive 16, and when you square that term there, you get plus 16. So what we've done is completed the square. So now we can use that to do a substitution, or to complete the square of the denominator, so we can actually do a substitution. So the integral of, with respect to the x, of x squared minus 8x plus 30 is equal to the integral with respect to the x of x minus 4 squared plus 14, and we can write 14 as square root of 14 squared. Now from work done previously, this is like a x squared plus a squared. So we'll let u equals x minus 4 here, and say du dx is equal to 1, and because we want to do a substitution for dx, we'll say du equals dx. Multiply both sides by dx there, and we get du equals dx. So therefore our integration now becomes, so the integral to x of x squared minus 8x plus 30 is equal to the integral, instead of dx we're going to write du, I'll put that at the end, of 1 over, now x minus 4 we said is equal to u squared plus root 14 squared. That is a pattern that you need to recognise, and that's 1 over u squared plus a squared, and that is equal to arctan. So this integral here becomes 1 over square root of root 14 arctan of u over root 14 plus c. Alright, using the fact that the integral of 1 over x squared plus a squared dx is equal to 1 on a arc tan of x on a plus c, obviously. Okay, so that's a rule that is well and truly worth committing to memory. You're going to use that quite often. So here we've got, with respect to u, our a is equal to square root of 14. So using completing the square, we're able to get it into this shape or this pattern, and this pattern allows us to use this substitution. And now the original question did not have a u in it, we have to do a back substitution. So that'll be 1 over square root 14 arctan. Instead of u, we let u equals x minus 4 on root 14 plus c. Okay, so completing the square, when you complete the square, it's always half the coefficient of x, and don't forget you always add half the coefficient of x, which is negative 8 on 2, and you square that. If you square that, then you've got to subtract the same amount so that it remains equal, and that allows you to write x, because that's a minus, that was a plus there, it would be a plus here, minus, and 8 on 2 is equal to 4. So then minus, this here becomes minus 16 plus 30, so we get x minus 4 squared, x minus 4 all squared plus 14. Then that allows us to do the substitution here for completing the square. Then we can substitute, instead of x minus 4 we can put u, find out what du is, and then do the integral, recognise the pattern and know that this is one that we need to remember, and we can do the substitution to get 1 on root 14 arctan x minus 4 on root 14 plus c.